Good day, folks. We have a problem here that seems pretty much impossible on the surface. We're supposed to find the smallest positive integer m such that this fifth degree polynomial is a multiple of this three-digit number. Okay, that just seems almost ridiculous, you know, but it's common in these competition type settings to actually do prime factorizations because it simplifies things. All right, so it doesn't take too long to realize that this is what they call a semi-prime. 29 times 37. Now, y'all, some time is required right here. So this is part, this part here would be time consuming. I just know that this is the approach. But you would, if you were a competitor in one of these things, they give you training sessions, and so you don't walk in cold on these exams. So anyways, the prime factorization or these competition problems, the factorization here is 29 times 37, which you'll see is quite useful. Something else that's very, very useful is that m is a zero of this by appearance. You know, m, if you substitute m equals 0, you get 0 out of it. That means m is a factor. Now notice right here something very, very helpful here. This is known to be minus the sum of the roots right here. The coefficient of x cubed for this fourth degree polynomial is minus the sum of the roots. But notice that a possibility here is 1 plus 2 plus 3 plus 4. Now, if any of the roots were repeated, there's no way this sum would just be 10. So what we have learned here, and again, you would, if you're not confident about this, you can always just, you can check to see if it's right, but sometimes you make kind of informed guesses here. But this is pretty solid here because you know you need 4 numbers that sum up to 10 and have a product of 24. Well, that's a very, I guess 1, 2, 3, 4 would, I'm not proving that here, but 1 plus 2 plus 3 plus 4, that should be a plus on there, right? Okay, is 10, but also the product, 1 times 2 times 3 times 4 is 24, right? And so what you get right here is the factorization, m plus 1, m plus 2, m plus 3, and our fifth factor is, let's see, we have m plus 3 right here, and then we have m plus 4. Now, y'all, I agree, you're thinking, wait a minute, if you're just giving this problem cold, this is a big stretch. But again, these guys, I don't know if they get coached, they take classes, and they know what type of problem to expect what types of problems and problem techniques to anticipate for these type of exams. So anyway, this is the factorization of our original expression, okay? Now, that gives us a lot of potential here to simplify our calculations. What we're really looking for out here, again, the prime factorization of our multiple here is 29 times 37. So we need to find multiples of 29 and 37 that are less than 4 apart. Where does that come from? Well, here's m, and then m plus 4 is 4 away from m, right? So that's what we mean by 4 apart. You could say a difference of 4 if you prefer more mathematical jargon. Okay, but so what we can do right here, folks, is just create a list. Now this is very, I like this. This stuff is fun. I'm going to list all the multiples of 29, and we just keep listing them until we see a pair of them that are within 4 of each other. Okay, so we got 37. So that would be the first multiple of 37. Now 58 would be next, right? Over here. You see, you're keeping your eye on the prize kind of. 2 times 37 is 74, right? Now, right here, if you add 3 times 29 is 87. You see they're getting a little closer. So you got 87 here. You see, so 74. Sorry, let me. It's a mess there. Let me get the eraser working here. Okay, so that should be 87 right there, right? But you see how 74 has crept up a little bit closer here? 37 was 21 away from 58. 74 is 13 away from 87, right? So let's keep listing here. What's 3 times 37? 111. Okay, now what's the next one over here? 4 times 29. You see how you're getting closer. It's kind of cool how this works out. 4 times 29 is 116. You see, these multiples grow faster, right? So they're going to kind of catch up, in a manner of speaking, with the column on the left-hand side. Okay, so we got 116 going on here. Now you see it very close. We're within 5, right? We need to be within 4, though. We're within 5 right now. So what 4 times 37 is 148. So we have 148 right here. Now let's add 29 to this, and we get 145, and that's good news. That's very good news. 145 right here. And you see how these meet the criterion 4 apart. These two guys are only 3 apart. Okay, so what do we have to do? Well, we have to find out where this 145 would have to be. I guess, let's see, can we put 145 right here? Oh, you know what? We're better off putting if we put 145 right here, it would be too big. You see, right here, just think of 145 being right here, right? Okay, that means 148 is right here, correct? And y'all, you see we are in fantastic shape, because this is a multiple of 37 and 145 is a multiple of 29, which is exactly what we needed to be a multiple of 1073. I hope that makes sense. All right. So, and notice that it was important. You're saying, well, why didn't we put the 145 here? Well, that would make it 1 bigger than it needed to be. You see, we're looking for the smallest positive integer m. And so that means if 145 is equal to m plus 1, that implies that m is equal to 144. And that's the answer to our problem. Okay. I thought this is super interesting, this approach here, because when you first look at the problem, it appears to be intractable. Just think about it. A multiple of 1073, then you're having to raise these integers to the 5th power, to the 4th power, and do all these enormous computations. It would be impossible, for a human to do that. However, if we get the factorization done and then consider the prime factors of our constant here, then that really makes life a lot easier. And then there's the last bit of logic here. It's very tempting just to put the 145 right here, and that would put the 148 right here. But you see, that would be 1 bigger than 144. So there's some logic even at the end. Where do we place things to keep everything going? And the beauty of this problem is we didn't have to know anything about what the actual magnitude or the Hindu-Arabic form of this integer was. But whatever it is, it's 144 times 145 times 146 times 147 times 148. Okay, huge number, but we don't need to know, because they didn't ask us for that. They asked us for the smallest positive integer m, such that's yada, 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 right? So 144 is the answer. Let me know what you thought.